So just to remember, we talked yesterday, we did a lot of stuff yesterday, obviously. We did 4 lessons, well, 4, we didn't quite finish 4 lessons, but 4 lessons. Boyle's law does pressure volume, right? If the volume goes up, the pressure has to go down, remember, okay? Or vice versa. We did Charles' law, which does volume and temperature. Volume goes up, the temperature has to go up. Volume goes down, temperature goes down. And again, if we're talking about Charles' law and it's volume and temperature, we have to leave P alone. P has to be constant. And we did Gay-Lussac's law, which is pressure and temperature. And in that case, of course, the volume staying the same. Okay? And then we said, hey, there's a magical formula that does all these things together, which is P1, V1, T1, P2, V2, and T2. And we looked at 2 examples yesterday where we kind of said, oh, okay, let's just start with this formula and say, okay, if the temperature's staying the same, get rid of it, right? I gave you an example yesterday and some of you look confused. Let me do this instead. This is way better. This is what happens when you are the first guinea pig class. I wasn't thinking yesterday. I have a super easy example. Look, if you don't believe I can cross those 2 things out, okay? If you're still skeptical from yesterday, you can, okay? But if you're still skeptical and you don't believe me, watch this. Let's pretend for a second that if the temperature remains constant, let's pretend the temperature's 1 Kelvin. It's cold out today, okay? If this was 1 Kelvin and I put 1 Kelvin in here, does that now make sense that you probably don't need those there? Okay? Because what's P1 V1 over 1? Well, it's P1 V1, yes? And if this P2 V2 over 1, it's P2 V2, yes? So we don't need to worry about that. They're going to cancel out, okay? If there were 2's there, it's going to be the same thing, okay? It doesn't matter. So if the temperature stays the same, get rid of it. If the volume stays the same, get rid of it. If the pressure stays the same, get rid of it. Just please do know, like this, you should know that this is Boyle's law, okay? Because that is important. We need to know the relationships between P and V, okay? Now, yesterday we did a couple of examples, okay? And then we did one where there, I think it was the temperature was staying the same, the first one we did. And then the second one, I believe the pressure was staying the same, okay? I'm going to leave those 2 there. If you want me to do one more, I'll let you, we'll do that. I can do that. But I'm going to move on to this one here now. So let's find this example here somewhere on your sheet. It says a 15-liter weather balloon under these conditions, 38 and 80.5. Okay, it's a weather balloon one. There's 2 balloon questions, so be careful with that. I think we've already done one of the balloon questions. This, is it on the back? Is it on the front? The very first one? Very first one. Perfect. Okay. The very first one. Okay, front side, very first example. So, this, by the way, is something else we need to talk about today. All right? And I kind of skipped this part over. I believe it's in your notes. Okay? But it was a while ago, but I skipped it. And my bad, I should have done that first before we did any of this stuff here. So before we get too crazy here, I'm actually going to go back to lesson 3 for a second. Okay, this is back in lesson 3. And I kind of go back because I missed this yesterday because I got excited about confined gas law. I'm not going to lie because it is exciting. I'm not lying. It's actually exciting for me. It is. I swear. I love T1, V1, T1, P2, V2, T2, out of the Bach. Terminator. I'm doing the Terminator. T2. Yeah. Okay. Back in lesson 3, before I got all excited there, we kind of did this. We did this. We talked about. Remember, I drew a diagram of the guy on the mountain, and we joked about you go to the top and boil your noodles there because it'll be quicker. And we talked about all this stuff here, yada yada. We did this. What I didn't do was this. Okay. So, going forward here, okay, there is something called some standard states, and it is a set of conditions that are agreed upon by convention. You do not have to go back to lesson 3 if you don't want to. Okay, it's fine. Just watch this, and I'm going to tell you. These are on the back of your periodic table as well. Okay, so these are there for you again. But you're going to see these abbreviations at some point, guaranteed. Okay, And basically what it means by agreed upon by convention is some scientists got together and said, hey, what kind of conditions do we want to study gases at? What makes sense for us? So they decided, well, let's do some studies at 0 degrees Celsius or 273.15 Kelvin, and let's use a pressure of 101.325 kilopascals. Okay, so they decided, hey, those are two conditions that we want to use over and over and over again. So we're going to call those conditions standard temperature and pressure. Okay, so when you see the STP, by the way, STP is standard temperature and pressure, not the Stone Temple Pilots, okay, which nobody knows of anymore, right? Be a great band back in the 80s, 90s. STP, standard temperature and pressure. When it says standard temperature, this is actually standard pressure as well, okay? So standard temperature and standard pressure. These are the conditions we're going to use. So we're going to use a pressure of 101.325 and 273.15. There's two numbers basically that we are looking at when we talk about STP. Okay? So if you see this in the question, those are the two numbers that we also want to include in this question. Okay? There's another one called SATP, which stands for standard ambient temperature and standard ambient pressure. Okay? Standard ambient temperature, standard ambient pressure. That's what that stands for, SATP. And SATP is 25 degrees Celsius, or 298.15, okay, and 100 kilopascals. So if you see that capital SATP in the question, those are the numbers you want to use there, okay? Again, they're just basically constants. They're on the back of the periodic table for you, okay? So when we look at our question today here, just so you know, in case you're wondering what I'm doing with this, is the first thing you're going to see here is it says a 15-liter weather balloon is released under STP conditions, okay? So right away, I'm going to tell you that there is some numbers here that we didn't write out, but they are assumed to be there, right? So again, we're going to look up the STP numbers on the back of the periodic table, okay? And yes, you get the periodic, again, you get a periodic table for every quiz, every test, yes? So if it's on there, you use it, okay? After 10 minutes, we get minus 38 and 80.5. Calculate the new volume of the balloon. What letter, what variable are we looking for here? Somebody, huh? V2, okay? So we want to find V2, okay? And I guess your first thing, of course, would be this. Do you think, or do you see here, well, let's talk about this. A 15-liter, this is obviously going to be V1, yes, 15-liter weather balloon. Under STP conditions, there's T1 and there's P1 there, yes? So we're going to let a 15-liter weather balloon go under T1 and P1 conditions, yes? After 10 minutes, the temperature becomes minus 38, T2, oddly Bach, and a pressure of 80.5, okay? Is anything staying constant in this one? Is there anything that we can cross out in this case? There is not in this case. So again, we always start in the same spot no matter what. We're going to start with P1. I'm going to run out of room here, so I'm actually going to move this down here. P1 V1 over T1, P2 V2 over T2. Now, Julia says we need to solve for V2. So how do we do that? You have options. I'm not going to tell you what to do here. However, okay, we do have to make sure V2 is on the top, okay, and we should be able to solve for this, which we can, yes? Okay, there's just a bunch of letters here. Again, how are we going to get this by itself? How are we going to isolate V2? So most people would say, well, what's one option? Yep, times the T2 on both sides. So I'm going to get rid of this, and I'm going to put that over there. Yep, like that. Okay. What else do I need to do? Do I have V2 by itself yet? What else do I need to do? I have to get rid of what? Somebody, come on. Say it. P2. How do I get rid of P2? Divided by P2, right? So I'm going to get rid of P2, and I'm going to get rid of P2. Okay, I'm going to put it on the bottom, yes? Kind of like that. So that's an option, okay? And you have this solved now, okay? I'm going to give you another option. Okay, is that good? Yes? No? Okay. You could, like I said, there's a few options. I can see if I can get rid of all this stuff here. You could just say this. Hey, look, V2 is here. So basically what we did is the same thing, but if I want to get rid of T2 and P2, right, I got to multiply both sides by T2 and P2, yeah? Kind of like that. You could do that, which is exactly the same thing, just in kind of one step instead of two. Okay? Good? If you don't like that, like I said, I'm teaching my son right now, cross multiply. Okay? You got equivalent fractions here. If you want to make sure that you have everything on the top, okay, cross multiply, like so. So P1 V1 T2 equals, it doesn't matter what you write first or last or whatever, you know, 1 times 2 times 3 or 3 times 2 times 1, T1 P2 V2, yes? Cross multiply, right? Then everything is in a nice line now, okay? And if you want V2, where's V2? Right here. So I'm going to get rid of T1 and P2. Boom, boom, T1 and P2. I don't care, okay? You've got options. You decide what's going to work for you, yeah? Just make sure that the variable is on the top, okay? I'm going to tell you the biggest mistake that I see is people say this. Oh, well, here's T2 here. Let's say I wanted to solve for T2. Take a break for a second. Let's say I want to solve for T2. So people say, oh, I divide by P2 and V2. And they put P2 and V2 down here and say basically that's got rid of that. But you didn't solve for T2. You solved for 1 over T2, yes? T2's on the bottom. Okay? I'm going to give you a little tip here right away. Look, how many things are on the top? How many variables? 3, yes? How many are on the bottom? 2. Always. If you ever get 2 over 3, it's wrong. I'm telling you. Guaranteed. 100%. There's no such thing. Okay? You got to have 3 variables on the top and 2 on the bottom. It just helps if you just do it properly, obviously. But, you know, like I said, that's not an option. So this is kind of what we're looking at here. Okay? And then what I like to do is I like to sit down and say, okay, well, let's put some brackets here. 3 things on the top, 2 things on the bottom. And that should be V2. Okay? And I'm going to start putting some numbers in here. Okay? So this is where you have to be paying attention, though. Okay? You're not, just because you got this so far and you're like, oh, sweet. And then you can't put numbers wherever you want. Okay? I would be very regimented and say, okay, what's P1? That's got to go here. Okay? And I'm going to tell you why right away. P1 is, what did I say? Right there, STP. So I'm going to look up P1 on the back of the periodic table. It is what? 101.325, yes? So that's going to go here. I'm going to use my units, kPAs. Okay? What's V1? V1 was 15 liters. Okay? What's T2? Okay? This is the second most common mistake. You put the pressure or the temperatures in the wrong spot because now it was P1, V1, T2. Okay? So you have to be paying attention here and make sure T2 is what? Minus 38. Oh, crap. What is that? I want to say 35.15. Is it? No? Are you? I don't know. Help me. Is that right? Okay. So that has to go there. If you flip the temperatures over, it's going to be wrong. Okay, I guarantee you, yep.
I forget. How do you convert?
At 273.15. Yep. Then I go to T1, which is this STP thing there. So T1 is 273.15 Kelvin. Okay, back of the periodic table, STP, look that number up. And what was the last thing here I had? And a pressure of 80.5 kilopascals. Okay, and that's what you need to enter into your calculator properly as well. Okay, look, kPa cancels with kPa, kelvins cancels with kelvins. What do I have left? I have liters. Perfect. My answer is going to be in liters. Okay, now when you type this into your calculator, you got a couple options, but I'm going to tell you right now, if you type it in like this with no brackets, it's going to be wrong. Okay, so again, I would say, especially with these questions here, you're going to have to do something along this line here. When I say brackets, I mean 15 and 235.15 divided by, right, bracket. Okay? This is what I talk about when I say brackets, because I need to take the top divided by the bottom all together. People think when I talk about brackets, they say, oh, I'm going to put the brackets here and here. That doesn't count. It's still not the same. I need to take my 273.15 and multiply it by 80.5, close the brackets, like that. If you need to write that down for yourself, then do so. There's other options. You can do this in parts if you want. Sure. Get the top answer, get the bottom answer, and divide the two. Yes. You can't round, of course. But you can do that stuff. Sure. But if you're going to do it all in one step, this is what you have to do. If you want to put the top part in big brackets as well, so the top brackets divided by bottom brackets, sure, go ahead. Okay? But this bottom part definitely needs to be in brackets because we should get 16.3. Okay? Now, I'm going to write this number down here, 16.25. Yada, yada, yada. Okay? 16 point what? Okay. 16.25. Now, significant digits. Let's go back and look, skis. Again, how many do I have here? Okay. These are constants, so we ignore them. Okay. Don't worry about them. Okay. I don't care if it's 1 atmosphere or what. Don't worry about it. I'm not going to pay attention to that. Constants. Okay. What is the 10 minutes? That has nothing to do with this question, right? We're just basically saying, hey, after 10 minutes, I'm going to take these measurements again. How many's here? 2. How many here? 3. So how many do I need in my answer? 2. Okay. So because of that temperature there, it's not very accurate or precise. I need to only have 2 in my final answer. So my final answer should be 16. Okay. Is that good? Okay. Questions, anyone? Okay.